Okay guys, welcome back. Unit 10, Day 8. This is where it's going to start getting interesting. We are going to solve trig equations. So if you notice here in our first example, we're solving for x, but it's inside of a cosine function. So our first goal is going to be to get the cosine x isolated. So very quickly here, using some basic algebra, we'll subtract 1 from both sides. Then we'll divide by 2. So I end up getting cosine x equals -1/2. If you remember from earlier in the unit, we're going to take the inverse cosine to isolate our variable. Now, here's where it differs a little bit from when we first did our inverse functions. If you notice up above, it says from -2 pi to 2 pi. So all of our answers have to be in radians, and we want all possible angles between -2 pi and 2 pi. So now let's take into consideration our quadrants, A, S, T, C. Well, since cosine is negative, I need the quadrants where cosine is going to be negative. So that's the second quadrant and the third quadrant. So now, from prior learning, you guys should also be able to tell me where cosine is 1/2. So cosine is 1/2 at 60 degrees or pi over 3. Now I notice I didn't write down x equals pi over 3. I wrote down alpha. Basically, that's your reference angle. So what you need to do now is you need to give me all of the angles between -2 pi and 2 pi in the second and third quadrant that have pi over 3 as a reference angle. So first, let's go in the positive direction. So we start here. Second quadrant, pi over 3 is going to be 2 pi over 3. Well, if we continue, third quadrant, pi over 3 is going to be 4 pi over 3. So where it's going to get a little bit more challenging maybe is going in the negative direction, because notice I have to go to -2 pi. So in the negative direction I go this way. Well, that would be -2 pi over 3. And if I keep going to here, that would be -4 pi over 3. Now there's a little bit of a shortcut you can take with cosine. After we do a few more of these, I'll point it out, but you might pick up on that early. Okay, for our next example. Again, our first goal is to isolate the trig function. So very quickly, I'll subtract 2 tangent x over to the left side, which gives me 2 tangent x. I'll subtract 3, so that gives me 2. Divide both sides by 2, and you've got tan x equals 1. Again, notice here from -2 pi to 2 pi. So let's think of our quadrants. We do this for every problem. ASTC. You should also recognize that tangent is positive. Where is tangent positive? Well, that's quadrant 1 and quadrant 3. So since it's quadrant 1, and from prior learning, you have to be able to tell me where tangent is 1. Well, that's 45 degrees or pi over 4. So now what I have to do is I have to think, okay, there's pi over 4. Well, what's pi over 4 in the third quadrant? Well, that's going to be 5 pi over 4. So there are two possible answers. Pi over 4 and 5 pi over 4. Now going the negative direction, this is where it gets a little bit more challenging than cosine. I want pi over 4 in the third quadrant, but in the negative direction. So that's going to be -3 pi over 4. Again, it's all about knowing those radian families. And if I keep going all the way around that to the first quadrant, so that's going to be -7 pi over 4. Again, if you have questions on where I'm getting these values, you need to go back to your radian families and make sure you know what pi over 4, pi over 3, pi over 6 is in each quadrant. Okay, for our next example. Again, the goal is to get sine x isolated. So first I will subtract 2 from both sides. That gives me √2 sine x equals -1. Divide by √2. Sine x equals -1 over √2, which you should recognize from your triangles. So again, this is a little bit different. -pi to 2 pi. And let's think of our quadrants. ASTC, what we notice here, sine is negative. So where is sine negative? It's going to be negative in the third, and it's going to be negative in the fourth. So the first angle I want you to find is actually going to be the reference angle. It's not part of our solution because we don't have a first quadrant angle in our solution. Where is sine 1 over radical 2? Well, remember, anytime you see radical 2, it's really going to be 45 degrees. So our reference angle is going to be pi over 4. So let's start building our solution here. I like to do the positives first. You don't have to do it this way, but I want a pi over 4 going the positive direction in the third quadrant. So that's 5 pi over 4. Let's keep going. If we go into the fourth quadrant, my pi over 4 family, that's going to be 7 pi over 4. Now if you notice here, I'm only going to negative pi. Well, it doesn't really matter here. I'm still going to have two angles because you notice here I'm going to have a negative pi over 4. And that one right there in the third quadrant, but from the negative side, is going to give me negative 3 pi over 4. Now, it didn't apply for this particular equation, but if we were to have a second or a first quadrant angle in the negative direction, I would not include it because we were only going to negative pi. Okay, so let's move on to our reciprocal functions. In example 4, you can see we have cosecant x minus 2 equals 0. Again, the first goal, get the function by itself. Cosecant x equals 2. Something else you probably noticed in this example, we're in degrees, and our domain is 0 to 720 degrees. Now, here's what I like to do. There's several ways to approach this, but what I like to do is I like to replace cosecant with its reciprocal, so that's going to be 1 over sine x equals 2. And you can think of it as 2 over 1 if you'd like. And then if I want sine x by itself, because really the ultimate goal is to get sine x or cosine x or tangent x, because that's what we're familiar with, is we're going to take the reciprocal of both sides. So the reciprocal of 1 over sine x is just sine x. And the reciprocal of 2 over 1 is 1/2. So now it makes it a much easier example, very similar to one we did on the first page. Let's talk about quadrants. ASTC, I recognize that sine is positive. Where is it positive? First and second. Okay, so where is sine 1/2? That's one of the first ones you should remember. Sine of 30 degrees is 1/2, so I'm talking about 30 degrees, and I am in degrees here. So 30 degrees will be my first angle. So now what I need to do, I've got that one. Now I have to get what 30 degrees as a reference angle would be in the second quadrant. So that's going to be 180 minus 30. That's going to be 150 degrees. Now I don't have to go in the negative direction here because you notice we're starting at 0 degrees, but I have to go all the way to 720. So now ask yourself, well, what does that mean, 720? Well, that means we go all the way around the circle one time and then to here. And then we continue on to there. Well, those are just called coterminal angles. So if I want the other two angles, what I need to do is I need to add 360 to 30 degrees. So I'd have 390 degrees. And then I add 360 to 150. All right, so let's see, what does that give me? 410, 510 degrees. Okay, our next example. So again, isolate the function. I'm going to add square root 3 to both sides. That's going to give me 2. Cotangent x equals 2 square root 3. Then we'll divide by 2. That leaves me with cotangent x equals square root 3. So cotangent. This is the one time I want to think of that as 1 over tangent. I don't want to make this cosine over sine. That's going to equal square root 3. Now we can take the reciprocal of both sides. So basically here, you know, if cotangent equals square root 3, then tangent equals 1 over square root 3. Okay, so I've isolated the trig function. Now what I need to do is look up at my domain. I'm talking radians from negative pi to 2 pi. Let's talk quadrants. ASTC, and tangent is positive. Okay, tangent's positive in 1 and 3. Okay, so the first quadrant angle will be in my solution set. We need to know where tangent is 1 over square root 3. You recognize square root 3, it's got to be 30 or 60. The way I like to remember it is 1 over square root 3 is less than square root 3, so we got to be talking about the smaller angle, 30 degrees. So in radians, 30 degrees is pi over 6. Now we need to know what pi over 6 is in the third quadrant, so that's going to be 7 pi over 6, and that takes care of 0 to 2 pi. So now if you notice here, I need to go to negative pi. Well, if I'm going to negative pi, I'm only considering this one angle here. So in the negative direction, you need to know what pi over 6 is going to be in the third quadrant, and that's going to be negative 5 pi over 6. And that would be our solution for this equation. Okay, one more example for this video. 3 secant x minus square root 2 equals 2 square root 2. Again, let's isolate the trig function. I'm going to add square root 2 to both sides. That gives me 3 secant x equals 3 square root 2. And then we're going to divide both sides by 3. That gives me secant x equals square root 2. So maybe this one I'll go a little bit quicker. What I'm going to do now is I'm going to take the reciprocal of both sides. Don't forget to take the reciprocal of the right side as well. The reciprocal of secant is cosine. The reciprocal of square root 2 is 1 over square root 2. So we kind of have to be familiar with our reciprocal functions and understand in an equation you take the reciprocal of both sides. So now again, we think quadrants, ASTC, cosine is positive in the first and the fourth. So now, look at our domain from negative 2 pi to 2 pi. I need to know where cosine is 1 over radical 2. I think you guys understand by now that's going to be pi over 4, 45 degrees. So let's start talking about our angles, and I'm going to bring back that very first example we did. From 0 to 2 pi, I'm going to have pi over 4, and I need that in the fourth quadrant, which will be 7 pi over 4. So I've got pi over 4 and 7 pi over 4. Well, what's kind of nice about cosine, it only works with cosine, and it's just because the two quadrants where it's positive and the two quadrants where it's negative. If I go the negative direction, I'm going to have negative pi over 4 and negative 7 pi over 4. So once again, only with cosine, when I'm going negative 2 pi to 2 pi, I just have to put a plus or minus in each one. All right, so that concludes the first portion of this lesson. It's a little bit longer. We're going to do a second video for it. So please watch the second video, and then you should have enough information to complete the homework. And as usual, if you have any questions, feel free to reach out and contact us via email or Schoology. Thank you.